In the previous lessons, Josh and Arobindo interpreted logarithmic expressions in two different ways in the moldy food context, as the time at which the food has a particular amount of mold, and as the amount of time it takes for the amount of mold to increase by a particular factor. In this lesson, Josh and Arobindo will use these interpretations to explain why two logarithmic expressions are equal. They begin by exploring the growth of mold on the pizza over two time periods.
Janet is a researcher studying the mold growth on the pizza that triples each hour. She starts a new experiment by putting a single gram of mold on the pizza at time t equals 0. She checks the dish for the number of grams of mold, waits some time, and then checks again. She notices that the number of grams has increased by a factor of 5. She checks it a while later and determines the number of grams has increased by a factor of 11 since the last time she checked. However, she forgot to record the time. Draw a timeline that represents the growth of mold and estimate the total elapsed time.
Okay, I like your timeline. I like how you can see the times 5, the times 11. What factor does it increase over the whole amount of time?
55.
Okay, can you put that in? And how much time total has passed?
Do we even know?
Well, can you just represent it on your
It's
timeline?
I plus p.
Josh and Arobindo created a timeline to represent the growth of Janet's mold over a period of time. They labeled the first number of hours, from when the experiment started to when Janet first checked the mold, as time I, and they knew from the prompt that the mold had grown by a factor of 5 over this period of time. Next, the students decided to label the elapsed time between Janet first checking the mold, time I, and the next time she checked the mold as variable p. Over the period of time from I to p, the students knew that the mold increased by a factor of 11. Finally, the students were asked to determine the factor by which the mold increased from the start of the first period of time to the end of the second. Arobindo suggested that this factor would have to be 55. This makes sense because if it grows by a factor of 5 over I hours and then by a factor of 11 over p hours, then it must grow by a factor of 5 times 11, or 55, over the course of the total number of hours, which they represent as I plus p. Continue watching to see how Arobindo and Josh create a logarithmic expression to represent their findings.
So we want to estimate the total elapsed time. So it's this, and the growth factor is 3 because it triples, and
Okay, so you think it's log base 3 of 55?
yeah.
And if a log is an exponent, what exponent are you seeing?
Each time there's a times 3, and you need to we're trying to figure out how many times 3's to multiply to get the times 55.
Okay.
Because each time there's a times 3, it also goes up by 1, which would tell us the total amount of time. Okay, so you'll have another times 3, and it would be like at 9. Then you'd have another times 3.
So what's your estimate for the answer?
It's between 3 and 4.
And how do you know it's between 3 and 4?
Because this is the 3, and we couldn't make it all the way up to 4. Because if we multiply another times 3, it goes to 81.
What about I? Do you have an estimate for I?
Yeah, it's in between 1 and 2.
In this episode, Arobindo and Josh were tasked with creating a timeline that represented the growth of their mold, as well as estimating the total time that had elapsed. After creating the timeline and determining that the factor by which the mold increased over the total elapsed time was 55, Arobindo suggested that the time it took for the mold to increase by a factor of 55 was log base 3 of 55. He explained that 3 is the factor by which the mold increased each hour, and 55 was the total factor by which the mold increased. Arobindo explained that since the amount of mold tripled each hour, he knew that it would have grown by a factor of 9 in 2 hours, or 27 in 3 hours, and so on. Using this, he was able to determine that the total elapsed time had to be between hours 3 and 4, because the amount of mold would have grown by a factor of 27 over 3 hours and by a factor of 81 over 4 hours. Similarly, Arobindo was able to determine that the first amount of time that had passed, I hours, had to be between hours 1 and 2. Since the factor 5 is between factors 3 and 9, it must have taken between 1 and 2 hours to do so. In the next episode, Josh and Arobindo will explore how another student reasoned about this problem and will create another logarithmic expression for the total elapsed time.